We are live. Hi everyone, welcome back to Codera. Today in this video we'll be discussing the LeetCode daily challenge for 29th of January. The name of the problem is largest rectangle in a histogram. Previously this problem has been asked in a lot of companies like you can say Google, Uber, Apple, Amazon, Microsoft. Every company has asked this particular question. So consider giving me a plus one in the chat if my voice is audible to everyone and my screen is also visible, and then I'll start with this problem in a while. So as I told you, this every other company has asked this particular question, right? So that is why this question becomes necessary for us to do. And like before starting, if all of you have joined today's video, so one thing that I would request everyone, if you haven't subscribed this particular channel, that is Codera, so you can consider to subscribe our channel, because on this channel we are regularly trying to put in a lot of videos related to codeforces editorials, atcoder editorials, and apart from this LeetCode daily challenges, Kabir is also doing a lot of live streams, so you can consider to check out our channel. Now coming back to this particular problem, so consider giving me a plus one in the chat if everyone is able to hear my voice, and then within a while I'll start with this particular problem, right? I'll just wait for 1 or 2 minutes for everyone else to join, and then we'll start with this particular problem. Okay, so the problem says that you have to find the largest area in a histogram, right? The problem is very much simple. The problem says that you have to find the largest area in a histogram. It says that you will be given an array of integers, heights. So you'll be given an array and you have to represent the histogram bar height where the width of the bar is 1, and you have to return the area of the largest histogram, right? So like if you have this particular thing, right, if you have this thing like 2 1 5 6 2 and 3, if you have this particular example, right, so in this particular case what you can observe is that there would be several answers, right? If you want me to tell, so let me give me some time, I'll make it. So this is what 2 1 5 6 2 and 3. Okay, so this is nothing but 2 1 5 6 2 and 3. You can give me a plus one in the chat if everything is working fine, right? And this is 1, then I would be having a 5 like this, then I would be having a structure which would be of height 6 like this, then I would be having a height of 2 again, and then I would be having a height of 3. So I know the drawing is not looking that good, but you can just focus on the logic, right? So if I have things like these, I can have a lot of rectangles, right? One rectangle could be which is of height 1, and I can make a rectangle of height 1, and all these areas would come underneath of it, right? If I have a rectangle of height 1 like this, then these areas would come under it, right? Another thing that I could do is, like, if I do not do it this way, so there could be another ways as well, right? If I'll talk about those ways, so it could have happened that I make like I could have chosen these two rectangles, right? I could have chosen these two rectangles, and these two would have done the job for me as well. Let me just clean this up so that I can talk about this, right? Another thing that could have happened is, let's say this is like looking like this, and this was the structure, right? Yeah. So another thing that could have happened if I took this particular height 5, and then this is the rectangle that I can have, right? So are we able to go to get to some conclusion or not? So I'll try to make this again, and then we'll try to see like what's the actual answer that we can get. So if I have one is at I have the height 2. Oh, just let me write this. If one of them I have their height as 2, I have one of them height as 1, one of them I have height as, let's say, 5 6, then again it would be what, it would be 2 and 3, right? It would be 2 and this would be 3, right? So for this particular example, if I have to consider it, so this height is 2, let's say this height is 1, all of the widths would be the same. So this height is 5. Now let's suppose this height is 6, this height is 2 again, right? If this height is 2 again, so let me draw it. So this height would be 2 and this height would be 3. right? So what I can do for this particular thing, right? What I can do for this particular thing, now I need to find the largest rectangle, right? I need to find the largest rectangle in this histogram, right? I need to find the largest area in this particular histogram, right? This is the target that I want to achieve. Now what I could do is I can choose a lot of I can mark a lot of indexes, right? Let's say I have two indexes, I and j. Let's say I'm currently standing here. Let's say my I is equal to 0, and maybe I have a j. Let's say the j is moving somewhere. Let's say from this particular index up till this particular index, if I'm trying to check, right? So I know like for till this particular index, so whatever would be the index, let me write the index numbers. So this would be I is equal to 2 1, this would be I is equal to 2, this would be I is equal to 3, and this would be I is equal to 4, this would be I is equal to 5, right? So if I'm talking about this part, so if I'm here till here, if I'm considering, so that would be what like I will have a I which is standing here, and these are the indexes that I would be having. Let me, instead of writing for I, let me just rename them. Okay, so if we have this as the index 1 2 3 4 5, like this is the indexes of I. So I can mark a j here. Let's say j is equal to 4, and from this index till this index, if I'm considering from here, like from here till here, all the rectangles, right? All the rectangles, then what will I, which rectangle will I consider? I will consider this rectangle 1, right? If I'm considering all these rectangles, if I'm considering this rectangle, this rectangle, this rectangle, this rectangle, and this rectangle up till these indexes, so what I'll consider, I'll consider that okay, my width would be nothing but width would be j minus I plus 1. Why it would be this? Because 4 minus 0 plus 1, because I have total 5 bars in between, right? So that's why it would be j minus I plus 1. So the width would be nothing but j minus I plus 1, right? Like this, width would be nothing but something like a j minus I plus 1. So I'll say okay. Now the thing is, what would be the height? What would be the height in that particular situation? In that particular situation, I can safely say that the height would be nothing but the minimum height, the minimum a of I, the minimum rectangle. This height is 2, this height is 1, this height is 5, this height is 6, this height is 2. So I know that the height that is consistently maintained in this particular width from the index I is equal to 0 till index j is equal to 4 is nothing but this particular height, right? This particular height 1, because everyone is having at least this height. So that's why the height would be the minimum in the range I to j, right? The minimum in the range I to j, the minimum height in this range, right? So this much part must be clear. Now you must be wondering, like this is perfect, but how will we find for all the possible combinations, right? So for this, what you could do is you can first of all have a answer that is the maximum area that we will be having. Maybe you can mark your maximum as 0, right? After that, you can start I, let's say like this, for I starts from 0, I is lesser than n, and something like this, right? And then you can start, like you can mark your minimum, the minimum height as something like int underscore maximum, that is the infinity. You can mark initially the minimum height. Then after that, what you will be doing is, for j starts from j starts from I, or j starts from I plus 1, depends on you, j is lesser than n. Let's say j starts from I plus 1, right? J starts from I plus 1, j is lesser than n, and I do j plus plus, right? So what would be the width? The width would be nothing but j minus I plus 1. And what would be the minimum? The minimum would be nothing but minimum of mi comma a of j, right? Up till now, whatever is the minimum, right? So my answer, maximum answer, would be nothing but maximum is equal to max of maximum comma width into mi, because mi would be the maximum height that I can achieve up till there, right? So this is how I'll be doing it. So if I look at the first loop, it would be order of n. If I look at the second loop, it would be order of n again. So the overall time complexity for this particular approach would take order of n square, right? So as you can see, like if I do it in a brute force manner, so it will take order of n square time. Now let's discuss about one more logic here, right? Let me just move up a little bit, and let me just clean this part. Okay, so let's discuss about one more logic in this particular part, like what we can do alternatively if I have to think. So if I have this particular rectangle, right, one of the things is that we did brute force, right? We initially we just try to find all the segments, like all the segments between I to j. We try to generate like all the widths that we can have possibly, right? And then we try to do it. But another way could be that instead of depending on the I and j indexes, what we could do is, we have this as 2, we have this as 1, we have this as 5, 6, this would be 2, and this would be 3, right? This is what we have. So what I could do is, if I am standing at this particular thing, right? If I am standing here, right? If I am standing at this particular rectangle, so I know that this particular rectangle, if I assume that this is the minimum height, right? If I assume that the minimum height that I am having, that is the height of the currently the height that I am considering is nothing but my height. So in that case, what I could do is, I could check towards its left and towards its right, that if I check here, so this won't get included. If I check this, so this rectangle would get included because it is having at least a height of 5, so that is why this also gets included. After that, towards the right side, I do not have anything, so that's why it's not getting included, right? So if I see the j is equal to 6 here, right? J is not equal to 6. Sorry, I am not talking about the indexes correctly, right? So if I talk about the indexes, so this would be 0, this would be 1, this would be 2, this would be 3, this would be 4, this would be 5. So this is j and this is I. So j is 3, so 3 minus 2 plus 1, that is j minus this is nothing but j minus I plus 1, so this would be nothing plus 1 plus 1, that is 2, right? So in this way you can see that I will get the height, and I'll multiply 5 into 2 and I'll get the height, right? Sorry for that. Okay, this is something that I can do now, but can I do it efficiently? Like what I'm saying is whatever rectangle you are choosing, whatever particular current height or particular index that you are choosing, let's say you choose this particular index, right? If you choose this particular index, then you move towards its left and find the next smaller element, right? Find the index of the next smaller element, and that would be the region at which you will be stopping, right? If I talk about this thing, right? If I talk about this particular index, right? If I am talking about this, so what's the next what is the index I, left index I, such that what is the next height towards its left that is smaller than it, next smaller element? So this is this is the one, the height one, right? So I'll mark my I as 1, right? And if I see on the right side, so I can easily observe that I have this height, so this height is included, and then I have exceeding, right? I am exceeding, so that would be nothing but 6, right? So, or you can say 5 only, right? If I am at 5, so 5 minus 1, like things like these, right? You can easily observe that this and this would be included, right? Don't worry on the index, this and this would be included, right? So what I'm doing for each, if I assume, what I'm saying is, if I assume that the current height, current rectangle that I am at, if I assume that AI, assume that AI is the current height of my rectangle that I want to build, then I search towards its left, that whatever is the nearest smallest towards the left, right? Next smaller element towards the left, next smaller element towards the left, and next smaller element towards the right. In these particular cases, I will be able to do it if I have the access to the next smaller element towards the left and the next smaller element towards the right, then I will be able to do it. Now if I am currently I am running a loop for I starts from 0, like this, let me tell you. So if I am running a loop for I starts from 0, I is lesser than n, and I plus plus, something like this, then I am running inside this loop, I am running one loop for finding the next next smaller element towards the left, right? And I am also running one more loop to find the next smaller element towards the right. Okay, so these two loops individually would take order of n time. So that's why if you have an outer loop which is taking order of n time, so the overall time complexity would still be order of n square, right? So in this, the concept is that there is a thing that is, if you want to find the next smaller element towards the left and the next smaller element towards the right, so you can have it and you can store it. You can store all those things in a stack, right? You can do this and this using stack, right? And you can have an array in which you'll be storing this thing, right? What is the problem? The problem is that if you choose this particular a of I, if you are choosing this particular a of I, then you want towards its left and towards its right, that what is the index? You want the indexes of the next smaller element towards the left and the next smaller element towards the right in order of 1. Only then you will be able to do it in order of n time, right? So what you can do is you can run a stack, you can use a stack, and you can implement these things like next smaller element towards the left and next smaller element towards the right. Once you have them, so you can store them into a vector, right? You can store them into the vectors, and like let's say this is let's say this we call this as right. Okay, we call this as right because next smaller element towards the right and next smaller element towards the left. So in the end, what I'll do, I'll assume that ai is my minimum height, so that would be nothing but this is the height, right? This would be the height, and then right of I would give me the next smaller element towards the right, the index of the next smaller element towards the right, and the left of I would give me the next smaller element towards the left that I won't be considering, and that is nothing but j minus I plus 1 that I am doing. So this would be the overall width that I want to generate. Like this would be what? This is nothing but the width that I want to generate, right? This is nothing but the width that I have with this particular height that I can afford to have, and this is the current you can say height that I am considering. So this is the width. So every time I'll be able to calculate it for all the indexes. So like I'll be simply running a loop for I starts from 0, I is lesser than n, and I plus plus, and what I would be doing is I will be having a maximum. So maximum is equal to nothing but max of mx comma a of I into right of I minus left of I plus 1, like this. Okay, every time I'll be doing this, and in the end I can simply return my mx. But before this, I need to calculate, I need to pre-compute my right and the left array, right? What does the right array store? The right array is storing the index of the next smaller elements towards the right, and the left is storing the next smaller element towards the left, right? These are the things that I'm doing. So let me show you the code part for this particular problem, like how you'll be actually implementing it. So if I'll talk about the code, so it's pretty simple. Basically, you will be given heights, like heights means the EFI that I was talking about. Then I'll have a left vector to store the next smaller element towards the left. So what I would be doing is, like, if the stack is empty, like these are the things that you can also understand a little bit better, right? So if the stack is not having anything, so that means that I'll initialize my left to the -1 and I'll put the current element into my stack. Otherwise, like, I need to check, like, if the height that I'm having, if the height at the top, the index that I am having in my current stack, if it is greater than the ith height, in that case I need to pop all those things, right? So basically this is nothing but finding the next smaller element towards the left, index of the next smaller element towards the left, and this loop would help me to find the next smaller element towards the right using a stack high array, right? And after this, what I would do, I would simply have the thing, right? This is the result, or I can say maximum. So it would be nothing but the maximum is equal to maximum comma height of I into the right of I, that is the next small element to index of the next smaller element towards the right minus the index of the next smaller element towards the left -1. So this is how I would do, and it would take order of n time, right? So this is the approach for this particular problem. As I told you, this particular problem has been asked in a lot of organizations like Uber. It has also been asked in Google. It's also been asked in a lot of organizations like Microsoft, Amazon. It's also been asked in Apple, and it's also asked in Meta, right? So that's why this problem is pretty much important. You can let me know in the comments if any doubt is there, right? And the code will be attached in the description of this video. Thanks a lot for watching this video. Also, if you like the content, so you can